All right, guys, let's go ahead and get started on our wireless section. So the first thing we're going to go over, our first PowerPoint is going to be, part one of wireless, and this is going to contain probably 2 or 3 videos. But let's go over our agenda. So we're just going to have a brief overview of what wireless networks are. What is a wireless LAN? This is kind of going to go over the what, the how, the why, going to introduce some terminology. And then we're going to take a deep dive into wireless topologies and terminology. And these kind of go hand in hand because when I talk about a basic service set or a basic service area, that's a topology, but there's also a term that describes that wireless topology. So it kind of goes hand in hand. We're not going to get too deep into the AP modes here. We're going to talk about them, but that's going to be in our next section when we go over wireless LAN deployment and architectures. Then we're going to talk about radio frequency. So what is a Wi-Fi signal? How is it possible? What is the layer 1? What is that transmission that's being used from computer to access point at my home network to get me connected to the internet? So we're going to go over radio frequency. And then we're going to hit on antenna types. So when we're generating those radio frequencies, these Wi-Fi signals, we send them out via an antenna. And there's different types of antennas for different purposes. The ones you're probably used to at your home are omnidirectional, but we have dipole, directional antennas, Yagi antennas. So we're going to get into the different types and then how that affects the Wi-Fi signal, how that affects your basic service area. And then we're going to get into the wireless LAN frame. So kind of once we hit all these fundamentals, I kind of like to call this almost the layer 1 of wireless with the antenna and the RF and then topologies, that's high level overview, but I kind of try to build this off the OSI model, and that's the way I see it because RF and the antenna, it's that Ethernet cable, right? And then the wireless LAN frame, that's your Ethernet header, but instead it's 802.11 versus 802.3, so that frame actually has not a lot more, but has a larger header, another source address, and another destination address we have to be aware of. And that's going to cover this section. So first thing we're going to go over again is the wireless network overviews. So a wireless network, that's going to be Wi-Fi enabled devices and Wi-Fi emitting network devices that connect end users to the physical network. So that's a mouthful, right? So a basic summary of a wireless network. We have endpoints like this computer here that has a Wi-Fi NIC card. And in that Wi-Fi NIC card, obviously like we have radios that are receiving and sending a Wi-Fi signal, a wireless signal, either to another Wi-Fi enabled device or to an access point to connect back to the physical network that's going to get us out to the internet. So a wireless network, you can kind of just describe in an overarching term as any way for that endpoint to reach back to the physical network to get out to the internet. That's essentially all that analog Wi-Fi signal is doing. It's connecting to a device, or this transmission is there so that this device can either talk to another physical device or the physical network, and then transform the analog into digital ones and zeros to get internet access, to get network connectivity. So when we're talking about wireless communication in our homes and the enterprise, Wi-Fi is a term that we use, and that actually is a standard. We're going to go over standards and regulations in another video. Wi-Fi is a certification. So I can't just go make my own radio, put it into the same Wi-Fi frequency ranges, and say, hey, this is Wi-Fi. It actually has to be certified as a Wi-Fi signal to be sold, bought, produced, and marketed as Wi-Fi. But at the end of the day, you're just going to hear this a lot of times with wireless communication. Even you'll hear it wrong. Like you'll say, hey, connect me to the Wi-Fi, when really maybe you're connecting via Bluetooth. All use radio frequency, but Wi-Fi is a standard, and that is the term that describes wireless communication. So sometimes you even hear like a 4G hotspot. Be like, oh, it's using Wi-Fi to connect. No, it's actually using a cell tower to connect. And that's what we mean by getting the specifics of it. But being a network professional, you have to enable business operations, right? So it's important that users, stakeholders, directors understand these different terms and that you can describe them in an easy way. Wi-Fi is that access point at your house. Wi-Fi is that signal that's emitting from the thing right above us, sir, right? Maybe you're in a conference room and that access point's in there. And then Wi-Fi or wireless local area networks or wireless networks, they can be very simple. They can be like this ad hoc network here going peer-to-peer essentially or one-to-one. They could be like your home where you just have this one wireless access point. It does everything. You could have lightweight, autonomous, or cloud-based approaches to managing these access points that are emitting that Wi-Fi signal and connecting your users. And there's so many different architectures, use case, and topologies that we can implement that are all unique to your enterprise, your building, and your business's unique scenarios. You're not going to deploy Wi-Fi at a small strip mall shop that's 1,000 square feet the same way you would a multi-level 20,000 square foot office building that relies on strong internet to do the day-to-day business operations. You just won't. It's not possible. So a lot of these fundamentals you're going to learn, terms like RF, Wi-Fi, they're common, they're universal, but there's a lot of complexity when deploying that wireless network. Okay, and then going over some more wireless overview. So now let's get over what I like to call the major components in a wireless LAN. So if you're talking a wireless LAN, and the whole purpose of a wireless LAN is to connect Wi-Fi endpoints, let me change my pen color, to the internet, where you're going to have some hardware involved in that. And I like to think of three major components when you're talking specifically the wireless LAN and what's needed to accomplish this connectivity from Wi-Fi enabled device to internet. So the first thing you're going to need are those Wi-Fi emitting access points. So these are going to be access points that maybe sit on the wall or on the ceiling, and their responsibility, depending how you deploy them, their main responsibility, of course, is to send that RF signal and to create that basic service set to generate a Wi-Fi map for all of our Wi-Fi enabled endpoints to connect to. And then we have a wireless LAN controller that in our big environments, we're going to learn about this different deployments and architecture. Their whole job is to be the brains for an access point. And again, this depends, because if this is an autonomous access point, we don't need a wireless LAN controller. But this is still a major component when talking about developing a plan to deploy a wireless LAN controller, a wireless network, is do we need this server or service here to control our thousands of APs? And then another major component is actually the endpoints, right? Why do we need to deploy a wireless LAN if all of our computers have to be hardwired because there's some regulation we work at in this embassy? Maybe we don't need anything because we don't have Wi-Fi enabled endpoints to worry about. And if we do, maybe we bulk order the same laptops, the same phones for all of our users, and now we can kind of get down into the weeds of what we need, right? Well, we only have people using these wireless NICs and this Dell laptop or this Android phone. So let's just put them all on 5G because this radio signal and this phone does better that way. You can really get into the weeds there. And then, of course, the distributed network. The distributed network describes the physical infrastructure that you are connecting to over Wi-Fi. So what do we mean by this? So when we have our access points, that access point is going to be connected to a switch, that switch to a router, and off to the internet. Well, the distributed network, and this is a Wi-Fi term, is going to be this hardware or this physical devices here that actually connect users out to the internet. Whereas this AP that's connecting this laptop, that's a wireless LAN component, right? That's specifically for Wi-Fi and Wi-Fi enabled endpoints. But this distributed network is the actual physical infrastructure that connects this AP to the rest of the network and the rest of the enterprise. Okay, and then our next bullet point, let me go ahead and fix that. It says radial. I use Grammarly, and sometimes it just does crazy things when I'm doing my edits. So let's go ahead and fix that right now. So how do we get these Wi-Fi enabled endpoints to communicate? What's that transmission? We use something called radio frequencies. And these radio frequencies are going to have set channels that are going to have these standardized frequency ranges that are for Wi-Fi use only. So you guys are going to see this as 2.4 and 5 gigahertz. So these are going to be the frequency ranges, and there's going to be channels within this frequency range that define the wavelength that we're going to use to connect to Wi-Fi enabled endpoints. So what this is saying essentially is that if someone were to manufacture a phone and they don't put in a radio built in or an antenna built into that phone that can receive and transmit based off these frequencies, you're not talking to Wi-Fi, right? So we use radio frequencies as our transmission medium to connect our Wi-Fi enabled devices and access points. And then these Wi-Fi signals, when they're generated, they need to be propagated out somehow. So imagine you just have all this energy, right? And you're bottling it up and you're freaking out, right? What do we do as humans? We exercise, we go run. Well, that's the antenna for our radios that generate these signals. The antenna is going to be the way that Wi-Fi signal leaves the device. And there are many different antenna standards for Wi-Fi propagation that are going to be specific to a use case. So this omnidirectional antenna, that's going to be good for maybe that big conference room or conference hall where you need to talk to everybody. But maybe we need a directional antenna like this because we may have two buildings here that for some reason we can't run cable across. So maybe we do some air fiber is what we call it, where we're getting 1 gigabit speeds via that directional Wi-Fi antenna. Or maybe we just need a directional antenna so that our parking lot out here, no one can reach the Wi-Fi, so we can't have people war driving and trying to make a footprint of our network like hackers, right? So maybe we just put a directional antenna that only sends to the, maybe the east direction. So it doesn't go to the west direction out to our parking lot. So these antennas are going to determine how this Wi-Fi signal is propagated throughout the environment. It can also determine how much power we can get on that signal, right? If we're able to generate, maybe 60,000 milliwatts, we need an antenna that can support that. So these antennas are very important. And then that antenna standard, there's going to be actual standards held on that antenna that says, hey, when signal passes through you, you have to keep this level of attenuation. Meaning, when the signal passes through your antenna, you can't just add so much noise and interference that the signal becomes unreadable to that endpoint. And we're going to go over that when we go over antenna standards. Okay, some more wireless overview. So access points, kind of going deeper into some of our infrastructure, have different modes they can operate in. Meaning when Cisco develops an access point, we have to determine many different things. One, is this access point going to be used in a large infrastructure with other thousands of access points? Well, maybe we can build this access point only lightweight, meaning that it needs a WLC to be the brains and to control all its wireless LAN profiles, to control how it sends data. So in a lightweight mode, you have access points or laps that are controlled by the wireless LAN controller. And we don't mean just that this wireless LAN controller is pushing SSID profiles and encryption to it and telling it what encryption to use. We mean that pretty much this wireless LAN controller becomes the central point of all data. Well, data and control plane traffic from that access point is always going to go to the wireless LAN controller. It's going to do no layer 3 or really any layer 2 decisions here. And we call this split MAC, to where essentially the devices here that are connecting to that access point it's going through what we call a CAPWAP tunnel to learn how its traffic should get sent. And that's even at the local level. And we're going to get into that. Like when these two computers want to talk to each other, they still have to traverse that wireless LAN controller and come back down. This lightweight access point does not do that frame switching locally. And then we have autonomous mode. So this is what you're going to typically see at your house, small businesses, where that wireless access point, and I just circled the modem, sorry about that. Back. So this wireless access point here is going to do your routing, your layer 2, your 3. I bet it has some like ACL capability on it. It has maybe it's like you can deploy radius on it. You can set up content filtering all at this one device. That's going to be your router, your switch, your access point. It's doing everything for you in your network. Now, obviously, with an autonomous AP, this doesn't scale well, right? The moment you got to go past like 2 or 3 access points, you got to start thinking about some wireless LAN controller solution, some software-defined solution where you can control APs from a central location or just from your computer. Access points operating in autonomous mode, they're great for that small business that all they need is internet and they're good to go. You know, they're selling boutiques. You know, it's a boutique clothing store. They don't really care. They don't need a lot of different networks, guest network. They just need that one autonomous AP. These can be meshed. So this is my autonomous access point. I know it doesn't look as good as that photo. These can work in a mesh network, and I've deployed this at my own house, where these autonomous APs will talk to each other and kind of say, hey, you go on channel 1, I'll go on channel 6, you go on channel 11. Let's try not to interfere with each other. Let's match up our SSIDs to give our users some ability to roam between each other. But again, it doesn't scale well. Because these always need to be in range of each other for a strong signal to occur, for them to connect and send these management frames, that it doesn't scale well. Once you get past like 2 or 3 autonomous access points, maybe time to move on and think about a lightweight mode architecture. Then we have cloud-based. So a lot of my students always kind of don't understand the difference between cloud-based and lightweight. And there really is none except for the hardware investment, right? Your operational expenditure versus capital expenditure. So with you deploying a wireless LAN controller on your enterprise and your data center and your comms closet, you're taking on what's called the operational expense, meaning you have to hire someone that knows how to deploy, manage, and configure that Cisco wireless LAN controller. And then they have to sometimes, if you don't have it set up properly, be on site to make sure that this is secure in the comms closet, that it's getting its firmware updates. And essentially, your operational expense may go up if you want to deploy your own wireless LAN controller in your own enterprise environment. Whereas cloud-based is a little different. You see these access points, they're not autonomous, they're not thinking for themselves. They are being controlled from a central point off in the cloud somewhere. So this, we're talking Cisco, this kind of deployment could be like DNA Center. And that's kind of more software defined, but it could also be Meraki. And that's essentially where you're controlling your access points at your enterprise, at your office. And you can do it from the comfort of your house by accessing that cloud resource via the internet. So you don't have to be VPN into the enterprise network to control your access points. You can just get a web-based dashboard from your house that can control now your entire wireless LAN network. Now, we're not going to get too deep on the pros and cons because I'm not trying to sell you on off-prem versus on-prem. But just one thing to note is that, of course, with the cloud, you do lose a little bit of control, as in, you know, you may be getting a software as a service or infrastructure as a service, and now your capital expenditure, it could potentially get higher than your operational expense depending on how much of the cloud resource your business utilizes. So there's just a lot of different things to keep in mind. A lot of times for mid-sized businesses, maybe 25 to 100 employees, maybe you have an office floor, just the floor. This is probably a good solution because it's easy to deploy. You just got to go set up your Meraki access points, connect them off to a switch the router off to the internet, all based off that one broadband connection delivered by, Spectrum or Cox or Comcast, whatever your local area has. And now you can set up all your access points from Google Chrome. It is easy and it is nice. And then you can kind of scale that up even into, if you own the whole building, you can still scale your cloud access point deployment. And then another note here, before I keep going off into these tangents, no matter what mode, no matter how these access points are deployed to the user, they don't care. All the user needs to know and all they're going to see is the SSID that they're supposed to be connecting to. And that's either your business name or maybe that's your accounting department. They'll have something like, for example, Trepa-accounting department. Then we'll have Trepa-sales department. If they're a sales guy, all they do when they connect is they go down to, their control panel or their taskbar. They look like, oh, there's my Wi-Fi. They might even know the term SSID. So really all this to say that at the end of the day, what we need to make sure, again, being an IT guy, you are part of the business. It's your job to make sure the business excels through network availability and simplicity, that they just see an SSID, they connect to it, and they can go anywhere in the building and stay connected. That's up to you. So really, no matter what the mode, all the access points are going to transmit an SSID, and those Wi-Fi enabled endpoints are going to use that SSID to connect. And now we're talking the actual device, right? This actual computer here, it's connecting based off an SSID that it can see or that it can receive its signal. Okay, so that's going to do it for this video. We just went over, quick overview. Well, it wasn't quick, but overview of wireless, kind of just laying the framework. And after this, we're going to get into the terminology and topologies. So stay tuned and thank you for viewing.